Hello, in this video we are continuing our discussion of example 1 in section 8.6. So we are trying to find a power series representation. If we're given this geometric power series where we have the function, the series, and the interval of convergence, and we're trying to find power series representations and intervals of convergence for 4 different functions. We've already worked through part A, so in this video we're going to work through part B, where we have 1 over 1 plus x squared. So again, like we did in part A, we need to take our function and relate it to the function that we've been given, because pretty much whatever we do to the function to get a new function, we're going to do the same thing to the series. So the thing to notice here is that we can write 1 over 1 plus x squared as 1 over 1 minus a negative x squared. So we've essentially substituted in negative x squared for x in the function. So we're going to do the same thing in the power series. So this will be the sum equal to the sum from k equals 0 to infinity of negative x squared to the k, and we can write this so it looks a little bit nicer as a negative 1 to the k, x to the 2k. So then it becomes a little bit more apparent that what we have here is not only a power series, but an alternating power series. So that's our power series representation. Not too bad to get that. Now for our interval of convergence. Since we started with a geometric series, you should check to see if you still have a geometric series, okay? So if we go to what we have here, it is a little bit easier to see that we do have a geometric series. Specifically, r is equal to negative x squared. So it converges if the absolute value of r, which is going to be the absolute value of negative x squared, which is the absolute value of x squared is always positive, so that's just going to be x squared. It converges when x squared is less than 1. Now we can rewrite this a little bit more. If x squared has to be less than 1, then that's actually going to be the same thing as x being between negative 1 and 1. Okay, remember, if you take the square root of both sides, you have the positive root with the same inequality and the negative root with the opposite inequality. Or you can just think about it. Any values between negative 1 and 1, when you square them, you're going to get values that are less than 1. So again, like in part A, this is the complete interval of convergence. There is no need to check the endpoints. Let me change back to my original color. So our final answer then is the function 1 over 1 plus x squared is equal to the series, the sum from k equals 0 to infinity. I'll go ahead and write my form that looks a little bit nicer, although it doesn't really matter. So this is negative 1 to the k, x to the 2k, and this is true for negative 1 less than x and less than 1. And again, this could be written as absolute value of x is less than 1. So there's our final answer. We have the function, the power series representation, and the interval of convergence.